this, on A, all right, I ask you to do the inverse to undo this, all right? So we talked about this the other day. So what would you have said in words? How do we write this inversely the other day? Because I did this, made you odds and evens and did all that, and I had you do a couple and then do the inverse of a couple. So help me out. How do I start here?
I subtract 5 from 12.
Okay, it's 12 minus 5. Then multiply by 2. All right, now let's talk about that real quick. We see a half. If I multiply by half, that's the same thing as dividing by 2. So multiplying a half, dividing by 2, those are the same. So if I was thinking divide by 2, how do you get rid of divide by 2? You'd multiply by 2. So multiply by 2, and then
Wouldn't it be 12 plus 5?
that is the number. Yep. Thank you. So it's not minus because I got to do the inverse of that, which would actually be plus. Good, thank you. So 12 plus 5, then multiply by 2, then that's the number that we're looking for. Basically, what did we just do by saying all that? What was the easy way to ask you to do this? Solve for x, right? We just solved for x. But I had you write it all out.
Sure.
All right, yes.
The way you wrote it, I think it actually would be minus 5 because if it were plus 5, you'd transfer it over and then it would be 12 minus 5. Am I correct in saying that?
Well, I would add 5 to both sides. So I'd have the 12 over there plus 5.
Okay.
So it would be plus 5.
I see what you mean.
I wrote it incorrectly. I didn't do the inverse of it. All right? So for B,
Multiplying by 2, shouldn't it be dividing by 2 because it's the inverse?
yeah, multiplying by 2 would be the inverse of a half. What undoes a half?
What are we doing the inverse of? Are we
Of 1 half.
okay?
I got to get rid of 1 half.
I don't know.
How do you get rid of 1 half?
You do 2.
Multiply by 2.
Multiply by
Yeah.
2.
You could divide by a half.
I thought you were inversing the whole problem. So
Mhm.
minus 5 to 12.
Now, I'm not doing the opposite. I'm undoing this process. Okay? Remember the other day I had you write multiply by a half, or take a number, multiply by half, minus 5 equals 12. Right?
Yeah.
So I had you write that out, and then I had you trade with the partner, and then we did the opposite.
Yeah.
Then 12, add the 5, do the opposite of 1 half, which would have been divide by half, or the easy way to do it is multiply by 2. Okay? All right. B's a little bit tricky. Somebody help me out with that. We're going to start with 15. What are we going to do first? Not quite. Close. I got to divide by the 3 first. All right? Somebody asked, can I just distribute that 3? Can't do that because the 3 doesn't have a square and everything else does. So I have to go 15, divide by 3.
Wait, why do you divide by 3 first if Undos says x minus first?
Okay? Well, I'm doing the inverse though.
Oh, so you're doing the opposite.
So I'm going backwards. Remember when we talked really early in the year, we said SAD map? All right? Yeah. So there's not any addition and subtraction. You said, well, yeah, there is, but it's inside the parentheses, so I got to do that last. So divide by 3, then take the square root. I'm going to just put the symbol. I don't want to write all that out. Then take the square root. Then add 4. And that's my number. Okay. Last one. Tell me about C. What's the inverse of that? That's correct. That's what we've been talking about the last couple of days. So we're going to take the log base 5 on both sides. That's how we would undo this, okay? So that one's actually probably the easier one. I do log base 5 of 40, and that's the inverse. I don't know. I can write all that I'm saying out. I'm not worried about you writing all that out. That's what we're doing there. So we're doing the inverse. We're undoing it. We're solving for x, essentially, is what we're doing. Okay? So here's what I want to do. We're going to kind of talk about today, we've been talking about inverse operations. We're going to talk about inverse functions today. So we're going to build the inverse functions of things as we're going today. So here's how we're going to start. I'm going to use that first problem that we're talking about. So this one right here, except I'm gonna modify it just a little bit, all right? I want you to write it like that. 1/2 x minus 5 equals, not 12, but equals to y. So now it can be equal to a lot of different things, okay? So we've got an equation. The first thing I want you to do, I'm gonna give you a little bit of time, use what we did a while ago, but I want you to solve that for x, okay? Get x by itself. Solve that equation right there for x.
In words?
No, just in numbers. Just normal. We're back normal now. No English now. So get x by itself.
Wait, is that on the right, is that y?
That's y.
How do we get rid of y?
You don't.
We don't.
So what would be the first that you would do?
Add 5.
Add 5 to both sides. That's what we did a while ago, right? So plus 5, plus 5. So I have 1/2 x is equal to y plus 5. Then what?
Divide by 2.
Then divide by a half or multiply by 2, okay? So I'm gonna multiply by 2 because that would get 2 over 2 there, which would be 1. That's how I'm gonna choose to do it, all right? You could divide by a half if you'd like. That's gonna be a little bit messier. I'm gonna multiply this whole side over here by 2. So I could write it like this, or I could distribute that 2, and I could write it like that. Okay? Yes, sir.
Why can't you plug a 0 in for y and solve for x?
Because 0 is not y. I don't know what 0, I don't know what y is. Okay? So here's the thing. If I put a y there instead of a 12 like it did, then what is this? What's the picture of this graph?
Linear.
It's a linear function. It's a line. It's everywhere on that line, right? So I'm wanting to know where I am on that line, not just one spot right now. Okay? Make sense? Now, here's the thing. What would be the benefit of me writing it like this versus writing it like that? What would be the benefit of me writing it this way than writing it this way?
You could find like a specific x point.
I could find x's a little bit easier, right? Normally what happens, I give you an x, you plug it in, you go find the y. Or I give you a y, you go plug it in, you go find x, okay? And so, if I gave you x, would you plug it into the green problem or the blue problem?
The green one.
The green one, because then I could just divide it by 2, or multiply by a half, minus 5, and I got y. I got it, done. If I give you a y and ask you to find x, which one would you plug it into? The blue would be easier, right? Because times 2 plus 10, I got it, right? So the benefit of going through this, of doing this inverse, is now that I can find all the y's. If I had the y's, I can find the x's a lot easier. Now, does that mean I couldn't find the x if I had the y there? I would just have to undo the process every time. Now, so I like this problem right here, but unfortunately this problem right here, we don't see it written a lot like that, do we? What's normally by itself? What variable is normally by itself?
Y.
Y, or in this case it's f of x, or I'm going to change it to f of x, all right? So I have f of x equals 1/2 x minus 5. That's what that one is, okay? How I'm going to write this one right here is I'm going to use this notation right here. I'm going to use f with a little -1 as an exponent, all right? So if I use f of x with a little -1, that means inverse, okay? That means inverse. Anytime you see f of -1. And so on this one, what I would do is I would write it like this. So this is my original, and this is my inverse. That's how it would be written.
Wait, should
Alright.
2x be y?
Now, and that's what we're talking about right now. So now f of x is normally a version of y, right? So we wouldn't want 2 y's in there, correct? And so here's what it's saying. X is normally our input, correct? and y is, or f of x is normally our output. Okay, I'm gonna build a little bit more of this as we're going. And so, but what we know we did here, what did we really do here in this problem? What happened with our x's and our y's? They like kind of change places, didn't they? All right? So that's what's going on. Now, let me show you this. We'll walk through this and make it a little bit, hopefully this makes it a little bit clearer. All right? So I'm going to go graph this real quick. So what I'd like for you to do is we're going to graph this right here. All right? So in order to graph that, we probably need to come up with some x's, make an xy table, and go graph that. Actually, you probably could graph it just by putting it on the graph, but I want to get to the table of values. What would be some easy x's that I could go plug into that problem? 0, yeah. 1, -1. I'm going to use 2. Let's do this. So here's what I want you to do. Take these x's right here, -2, -1, 0, 1, and 2, and I want you to go plug them into this equation right there. And give me the y values. So take -2, plug it in. Take -1, plug it in. Which one did you plug in first? You plugged -2, just went straight down? I started at 0. Plug 0 in, because 0 is easy, right? 0 times a half is 0, minus 5 is -5. Alright? So if you started at -2, what happens when I multiply this by -2? Gives me -1. Yeah, the 2's canceled, so I got -1, minus 5 is -6. Alright? Same thing kind of happens with the 2. If I plug the 2 in, half of 2 is 1. 1 minus 5 is -4. All right? You might be able to guess what's in between there, but if I plug them in, -1 times a half is -0.5. Minus 5 is -5.5 or -5.5. And this one's -4.5. Okay? I still think you got enough room on there. I'm going to go plot those points real quick. Just draw you a simple little sketch on your graph. So let's take these points and let's go sketch on the graph. Let's put them on there. All right. So -2, -6, -1, -5.5. I'm probably not going to graph that one. 0 and -5 right there. And 2, -4 right there. So that's where that graph is. Okay? Again, it's just a simple little sketch. Okay. Next, what I want to do is I want to go get a set of values for f of x. All right. So in this table right here, we did x and f of x, or x and y. In this one right here, I want to get a set of table of values for x and the inverse of f of x. All right, I want to go get those table values. Okay. Now, what I'm going to do is I'm going to give you a couple x's. All right. So I want you to do these x's. I want you to use -6. I want you to use -5. I want you to use -4. Right?
That's it,
And just use those three. Where are we plugging these into right here?
just seven.
This second equation, the blue one right there. So plug them into this blue equation, get those values there.
Not the one that's equal to, oh yeah, the blue one. The one
You can do either of these two blue ones technically.
Not that one?
Yeah, you can plug it in that one too. Yeah, no, sorry. Yeah, plug it in this one. Plug it into this one, then we already fixed it. Plug it in that one. That's fine. Plug it in that one right there.
I think it's just better to solve it on your own. So I usually do whenever that happens.
All right. So what did you get for -6 when we plugged it in?
Negative
-2
two.
for -5. 0 for -4. +2. Now, here's what I'd like you to do. Look at the two tables. Compare the two tables. What do you notice? They're flipped. What do you mean by that?
The X's and the Y's take each other's values.
Yeah, the X and the Y's just change places, right? So the X's and the Y's have switched. So if we're doing an inverse, we've got the original and we find the inverse. Essentially what's happening here is our X's and our Y's are changing places. Okay? Our X's and our Y's are changing places. And we do that. So in our original, all right, our X's are input and our Y's are output. But in our inverse, all right, this is technically the Y. That's what you were saying a while ago. The input is the Y and the output is the X, is basically what's going on. So our input and our output just got switched if we're finding our inverse. Okay? Now, I'm going to go take those same points. I'm going to go graph them. So let's go take -6, -2, -5, 0, and -4, 2. Let's go graph them. Okay? Give just a little bit time to catch up with me, right? By the way, is my graph super accurate? Not real great, but I think we can still see a pretty good picture of what's going on here as we go, all right? How is the blue line and the green line, how are they connected graphically? Anybody see anything there? A pattern or a connection on this?
They're mirrored
They are going to intersect. Good.
They're-
They're intersect down here. They are mirrored where?
45-degree angle.
Looks like a 45-degree angle. All right. Do they look like they're flipped over the x-axis?
No.
Not quite. Doesn't look like they're flipped this way, but it does look like they are flipped over some type of slanted line, like a 45-degree angle. I would agree with that. All right. And so, if I were to draw that line in here, right there. Okay, so if I were to draw that line, they are symmetric over that line right there. If you're looking at the board, you might have to tilt your head sideways, but you got your piece of paper, you can turn your paper, that way we don't look funny, all right?
Is it
And
not-
so, huh?
Is it going over the, baseline, like
What line is this?
y equals x?
This is y equals x, okay? So this line, if we were thinking about this, if we were looking at the terms y equals mx plus b, well, I'm not worried about b because what?
It's
Going through 0, 0, okay? And it's got a nice up 1 over 1 slope. So this is the line, this is the parent function y equals x. So all inverses, if two equations are inverse functions of each other, they are reflective over the line y equals x. Okay, so that's one of the test things I could do on a graph. Why y equals x? Why do you think that works? how did we get the tables? What did we do? We switched the x and the y's.
Yeah.
So if this x is equal to that y, then it would be on the mirror of each other, alright? See how that's kind of working as we're going, okay? So they're reflected over the line y equals x. Alright, so let's go across the page, let's go to page 35 now. So on page 35, you have, this right here. Okay? So I'll give you a chance, read question 1, we'll talk about it here in a second. So on page 35, read question 1. What's it ask me to do on question 1? Make a table, all right? Write a table. What else did it give me information about to write my table?
Interval.
Okay, so I'm going to write it from -3 to 3. These are my x's. And it says integers. What is integers?
Whole numbers.
Positive or negative whole numbers. So if I'm going to build my table, I'm going to go x and f of x. And I'm going to go -3, -2, -1, 0, 1, 2, and 3. Okay? So I'm going to give you a little time. I want you to go find me these values. What are we going to do with these x's? Go plug them in and go solve. All right? I'll give you a little time to do that. You can do it by hand. You can grab your calculator, plug in the calculator as well.
I'm confused why it's giving me a negative number.
That's correct.
Oh, yeah, because it's cubed.
We'll talk about it.
Yeah.
Which of these values do you think we probably wouldn't have any disagreements about? Huh? 0. All right, so if I plug 0 in, 0 cubed is 0, plus 1 is 1. All right? These, I think, the positive ones, I think we probably all agree on. So what's 1 cubed? 1 plus 1 is 2. What's 2 cubed?
4. No, 6. 8.
8. What does 2 cubed mean? 2 times 2 times 2. 3 2s. 2 times 2 times 2. So that's 8 plus 1 is 9. What's 3 cubed? 27 plus 1 is 28. Could we have done those by hand? Did we really need our calculator? Hopefully not. Okay, now let's go on the negative side. Now, what's -1 and -1 and -1? -1, right? This is like when I'm doing laundry, all right? When I'm doing laundry and I'm folding socks, and then I get that one sock that doesn't have a match, that bothers me, all right? And so how many numbers do I have? I've got 3 of them. So if I've got 3 negatives, it's going to stay negative. So that would be -1 plus 1 is 0. -2 cubed would be -2 and -2, which would be +4, but then that other negative makes it back negative. So -8 plus 1 is -7. All right? And then this last one would be -27 plus 1 would be -26. Alright, everybody okay with that? Everybody understand kind of why that's happening? By the way, when I go graph in a minute, guess what? I'm not graphing 328 and 320, negative 326, because I got enough information otherwise, I think. Okay? Let's go to question 2. On question 2, use your table that we just created to determine the value of x when this is true. So what information did they give me here?
The Y.
That's the y. That's y equals that. So when y is negative 26, x is negative 3. All right? You go finish the rest. Go do B, C, and D. Probably shouldn't take you very long. I'll be pretty quick. All right, f of x equals 0. X is negative 1. F of x equals 1. X is 0. F of x equals 28. X is 3. All right? Everybody good with that? All right. On part C, it says construct a table of values for, what is that notation? Inverse. So could we go construct a table of values for the inverse?
Yeah, just flip.
Should be pretty easy, so just flip them. Now, I want you to write it like this, though. I want you to write it x and the inverse of f of x. So write it like this. Number 3 ought to be really easy. All you're doing is you're taking your other table and you're going to flip it. All right, so go rewrite your table. Okay? Everybody okay with that table right there? That's pretty easy. Now, is that right? Okay? How could I check that? So here's what I want to do. All right? Out in the margin on the right-hand side of the page, I'm going to work with you on this real quick. All right? So if I have f of x equals x cubed plus 1. So if I have that right there. If I ask you to write me the equation for the inverse, okay? So if I want you to write me the equation, or write the inverse equation. How did we start that from a while ago on the left-hand side of your page there? When we did the linear problem a while ago, how did we start that? How did we start writing the inverse equation? What did we do first? Subtract 1. So we would go subtract 1 from both sides. So f of x minus 1 equals x cubed. All right? How would you still keep getting x by itself? What's
Take
that?
3, or the power of 3 away from both sides.
Okay, we got to take the power of 3 away from both sides. How do we do that? Not square root, but yeah, cube root is what we call that. Cube root on that side, cube root over here. So we get this right there. Now, do you like the way that looks?
No.
No, it looks really weird, doesn't it? Correct? So our last step that we did a while ago is we fixed the x and the y's. All right? Because normally my x is my input and y is the output. And it's not going to be f of x, it's going to be the inverse. So we found the inverse is what we did. All right? So that is my equation. Now, why am I doing this right now? I'm having you kind of check this, all right? So if I were to do that, could I check this table, because it should match that equation, because that's my inverse equation, this is my inverse table. They should match. So let's plug in. Well, the easy one to plug in would be 1, correct? 1 minus 1 is 0. Cube root of 0 is 0. It works, all right? 2. 2 minus 1 would be 1. The cube root of 1 is 1, because 1 times 1 times 1 is 1, so that works. This one gets a little bit more tricky. Put 9 in. 9 minus 1 is 8. What's the cube root of 8?
4.
It is 2, all right? Now, how do I work that? How do I do cube root? I'm looking for the same 3 number that multiplies for 8. 2 times 2 times 2 gives me 8, so the cube root of 8 is 2. So it works. 27. 27 minus 1, or excuse me, 28 minus 1 is 27. Cube root of 27 is 3. So they work, all right? So you see kind of how this matches with that right there. Okay? Number 4. What conclusions can we draw about the table for f, which is the original, and f of the inverse? What conclusions can we draw about those two tables?
The sides have been flipped.
Say again?
F, or the y and x.
Okay, so x and y have been switched. So x and y switch. So that's what we're seeing there, that the x and the y are switching. All right? What is domain?
Domain is the amount of distance.
You said this. What is that?
Like how far left and how far
Which is what?
Movement,
X or y.
x.
Okay? So domain is all the x's that it could possibly be. What's range?
One.
All the way y's that it could possibly be. So we could say the x and y's are switching. Would this be a correct statement as well, the domain range switch?
Yeah.
Yeah, if one x and one y switch and all x's and all y's switch, then we could say that also. Okay, so the domain and the range switch. Okay? So here's what I want you to do. Turn to the next page. Sorry, you're going to have to do a little bit of flipping back and forth. All right? But on page 36, it asks me to graph on this page right here. Okay? What's it asking me to graph? F of x. Do you have all the points to graph this one?
Yes.
Yeah, so use your first table on the other page and go graph right there. You don't have to use the -3 and -26. Mhm. Yeah, that was where we said x and y switch. All right?
So graph the inverse or regular right now?
Graph the regular one. Graph the original one. We're actually going to do both. But graph the original one first, and then come back and we'll graph the inverse. I'll put it up there in a little bit. I'm giving you a chance to kind of get ahead of it.
Should we use a scale of 1?
Yeah, you can use one. You don't have to you don't have to graph all the points. So there's what my inverse should look something like right there. Okay? And then I want to graph not my inverse, that's my original. My apologies. All right, that's my original graph. Now let's go graph the inverse. So use the other table that we came up with. All right? Put the other points on there as well. That's what that graph should look like. Now, kind of a little bit different. We started with the linear one a while ago. This is a little bit more complex one. All right, what do you notice? Anything hold up true that we talked about in graphs a while ago? Okay, the domain and range flip. All right, so if you look here, that's going from -7 to +9. That's going from -7 to +9, so the range flipped. All right, the domain here is from -2 to 2. All right, the range here is from -2 to 2. So they flipped, so good. Anything else?
It looks like they're flipped symmetrically on that.
Mhm. That same line that we were talking about a while ago, it looks like they're flipped symmetrically across the line y equals x. Again, a little bit of error on my part on drawing, but it looks pretty close there. All right.
That's pretty.
So it's flipped across that, so that holds up true. Now, you can use that piece of information. If you had a graph and it said, are these inverses? You could look and see if they're reflected over the line y equals x. You could say, yes, they are, or no, they're not, based off of that. Okay? All right. Last thing, go to page 37. So on page 37, sorry I don't have it up here, all right? But it says make up your own, actually I think I have it over here, all right? Make up your own problem, and then we're gonna do it, all right? So we did one of these earlier. Please do not use that one. That's the one that we used a while ago. But you can make up any other one that you wanna make up. Y equals x plus 5, y equals 2x plus 4, y equals 3x minus 5 or 4. I don't care. Make up something like that. All right. When we do that, you need to go create a table of values. What x values would you probably use? Okay, -3, -2, and -1. I would need to use the -3. It just gave me 5, so I'd probably use those 5. That would be fine. But if you want to use -3, you can. It doesn't matter. All right. But that's probably where I would do. So here's what you have, next 5 minutes or whatever, all right? And once you go complete the table, pick a word problem or pick an equation, I don't care. You use one of these or make up your own. Do a table, then graph it, all right? It talks about some patty paper. We don't have any of that right now, so don't worry about that. On the next page, it asks you to do the inverse table, all right? And then go graph it on the same page there on page 37. So basically what you need to do is make 2 tables, inverse and original, and draw both graphs on the same one, and then we're done. Okay?
Can I just stick the table on the same page?
If you want to put the table on the same page, that's fine. All right? Maybe when you do the table, Austin, on that other page, I just say see the other side or something like that. Because if I grade that one page and nothing's there, makes sense? If something's on there, then I'll see it.